Hello, everyone. Welcome back to Math SAT Question of the Day. We have Professor Emeritus Seth Chaiken from University of Albany and his brother, Joel Chaiken. It's me. We have a SAT question. Looks pretty standard. Some SAT questions have tricks, patterns, special relationships. This one really doesn't. They just want you to essentially rationalize this complex number. You're never supposed to have an I in the denominator. Later, I'm going to ask my brother, Professor Chaiken, what is this? Why can't you have an I in the denominator? But that's not relevant to this question. Do this question straightforward, cut and dry. The thing here is neatness. Neatness. If you're not neat in this question, you're sunk. Seth, show us how neat you can do it. Show us how neat you can do this.
Well, a complex number with an I in the denominator can always be converted to a form in which there's no I in the denominator. And so to solve this problem, you have to know that the trick to convert the complex number that I'm about to finish writing, the way to convert this to a complex number in which the denominator is real is to multiply the top and the bottom by what is called the complex conjugate of the denominator. The complex conjugate of the denominator in question is 8 minus 2i. All to get the conjugate, all you do is change the sign of the imaginary term. Okay? Now, to make so the trick is to multiply the number as written on the left by 1. And of course, as in all arithmetic, when you have two numbers dividing each other and they're both the same and they're non-zero, you have 1. And now multiply the top and the bottom separately according to the rule for multiplying complex numbers. So let me not erase because it will mess up the thing. So let me.
I'll erase it, Seth. You do the numerator. Okay, fine.
Okay, so to get the denominator, I get 8 squared, 2i times minus 2i. Well, that is 2 times minus 2, which is minus 4, times I squared, which is a minus 1. So it is the product of these two terms is 4 is positive 2 squared, which is 4. Now this works because the cross terms cancel. And that's what please, ladies and gentlemen, try that yourself to see why. And now, to get the numerator, we use FOIL, at which I'm going to use 3 times 8. Oops, sorry. 3 times 8 and minus 5i times minus 2i. What is that? Well, minus 5 times minus 2 is plus 10. And I times I is negative 1. So it is minus 10 for the real part. For the imaginary part, 3 times minus 2i is minus 6i. And minus 5i times 8 is minus 40i. And so here is the answer. Now, I am not going to do the arithmetic until I really need to. Now we could, so which of the choices might it be? Well, uh, there's C and D where the denominator is pretty big. Well, 8 squared plus 2 squared is pretty big. So let me figure out 8 squared plus 2 squared, which is 64 plus 4, which is 68. Well, so 68 somehow relates to the denominators. Well, notice that C and D have denominator 34, and 68 equals 2 times 34. So maybe it's one of these. So let's check the real part. The real part is 38 minus 10, which is 28. So the real part is 28 over 68, but both of these are even. And so the real part is 14 over 34. Well, what's wrong? What went bad? Oh,
the lesson to be learned is it's really easy to make mistakes.
Yeah, 3.
But what I did, by the way, I blew off B and D because this number here is negative, right? See, negative 6 minus 40 is a negative number. So these positive numbers here are out of here. Goodbye.
Yeah.
Goodbye. Goodbye. So you immediately get rid of those two.
Okay. So 64. Yeah, the denominator is right. The numerator is the real part. 24. 3 by 8 is 24. Minus 10 is 14. So I made an arithmetic mistake here. Yeah. So the real part is 3 times 8, which is 24, minus 10, and that is 14. So this should be a 14. And then that's equal to 7 over 34, which matches this.
Right.
And then, however, Joel really had an insight into eliminating this more quickly. He realized that the imaginary part is negative. So he said that eliminates B and D. And now the only remaining choice is the one with 34 in the denominator. And so it has to be C.
So first of all, you really lucked out because you made an arithmetic mistake and you were smart enough not to make the same mistake that the people in Princeton said people are going to make. Because if you make an arithmetic mistake that they think other people are going to make, then you got a problem because then you're going to get the wrong answer. It's a good thing to make a mistake where the answer is not here. Because that means that you made a mistake and you just calmly, as Seth did, you just calmly say, I made a mistake. And you just calmly look for it, and then you find it. Yeah. So that's good. It's good.
So my advice for learning to handle problems like this is practice.
Yeah.
But be neat.
This is the only way to get this question right.
I talked about the arithmetic I was doing. I held intermediate results of the arithmetic in my head. And that the doing that without making too many mistakes is just a matter of practice. It's like doing a sport, playing tennis or basketball or baseball, and then etc. Good.
Yeah. The other thing that I want to comment about the way Seth did it that most people in high school are not going to do. Don't forget, Seth doesn't have a whole lot of high school experience. I have a little more high school experience. Although we both went to high school, is that not that many people are going to do it this way. They're going to foil it the traditional way. They're going to do 24 minus 6i minus 40i, and then they're going to do the minus 5i times the minus 2i. No,
some of them may learn if you do enough of these questions for practice with complex numbers.
Yeah,
you would realize that at the end you want to group.
Yeah, I know.
And so if someone who's done this enough will do that by where they will apply FOIL in a slightly different order.
Yeah, but most people.
So please get from us that when you have a complex multiplication problem, yes, use FOIL, but don't do it in the order that the teacher told you. Get the real parts first, and then get the imaginary parts.
Right. Complex numbers are not a big deal at the SAT. So you're actually, when you're taking the SAT practice test, you're not going to see a lot of complex number questions. So you're going to have to rely on what you learned in school. That's a very, very small part of the test. And there's that one thing about like every number can be written as a real part and a complex part, and that's what Seth's getting to. Seth knew that all complex numbers have a real part and a complex part, and traditionally, it's written as the real part plus the complex part. I think we're done with the video.
Well, the thing is, what we're really talking about is many different expressions for the same number.
Yeah.
And so as you learned in arithmetic, what is 10? Well, 7 plus 3 is 10. 5 times 2 is 10. 14 minus 4 is 10. There are many different expressions for the same number. It works the same way in complex numbers, except there's a much wider variety.
Right.
Right.
So, Seth, I have a question, but I think most people will want to jump ship here, and you should, because I'm going to ask Seth an interesting question I've always wondered about that maybe other people are. The question is simply like, hey, what's wrong with having radical 3 in the denominator? Like, what's the big deal? What's the big deal? And what's wrong with having a complex number in the denominator? It just seems to me like Seth said, numbers can be written different ways. Like, what's the big deal? So most people, goodbye. If you care about this, I really want to know, like, why is everyone get so upset about this? So anyway, have a great day. We hope we gave you some insight. This is a cut and dry question. You just rationalize the denominator by multiplying by the conjugate. And Seth said, I said, the most important thing, neatness. You can be as neat as you want. Seth still got it wrong. Okay, so goodbye, everyone. Okay, what is wrong? What's this whole big deal? Why can't you write the number here? What's wrong with having 3 divided by radical 6? Why does everyone get so excited? Why does people ever say, oh, you can't do that. You can't do that. You can't do that. No. You got to do this. You got to do radical 6 over 2. No.
Well, Joel's right. I'd say it's for the same reason. It's for the same reason that people prefer to write 27 over 3 times 9.
Right. I mean, I always say it's the same reason as to why on a test, if you dared to answer the question as 24 over 2, the teacher will mark you wrong.
Yeah.
So you saying it's just...
No, so that's one reason.
Yeah.
Well, why is 27 preferable to 3 times 9?
Okay.
Well, here's a deeper reason.
Okay.
27 is also equal to 30 minus 3.
Right.
Now, if you did not write these two numbers in the standard form 27, and somebody wrote 3 times 9, and somebody else 30 minus 3, it takes work to tell that they're equal.
Right.
But if somebody wrote 27, and then another person wrote 27, we could immediately tell that they're equal.
Oh, so in other words, you're saying that it's in like simplest, in some ways it's simplest form.
Not necessarily. It's simplest for ordinary arithmetic, but for complex numbers, it's better to say standard form. And for what do you call it? Algebraic numbers, it's also standard form.
I see. In other words, there are different ways to write. There are different ways to write this. Is that what you're saying? So a radical 6 over 2 can be written in different ways.
Yeah.
I see.
Now, if we go back to the SAT question.
God forbid. I don't want to doubt that.
We go back to the SAT
Okay,
question.
okay, 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 okay.
The SAT question was simply, here is a complex number. It's a well-defined complex number.
Yeah.
And then they're asking for these 4 other complex numbers, which one of the 4 is equal to this? Well, it's hard to tell.
Well, yeah, of course.
But however, they did have the courtesy to put the 4 choices into standard form.
True.
And so, what you ought to do to solve the problem is take the complex number given here and convert it to standard form using a method that is standard.
Right.
And then you could immediately tell which of these 4 is equal to.
Right.
Now, we took a shortcut because the answer to the question is either A, B, C, or D. And so what we did was use particular sub-features of the choices to eliminate all the choices until we eliminated all but one.
Right.
But if you were given a test where the goal is to write this in standard form, you have to work out all the math and come up with 7/34 minus 23/34 of I.
Right. Okay. Sounds good.
That's good. Yeah.
Okay, everyone. Have a great day. Don't forget to like us, but more importantly, dislike us, because we need comments. We need criticism, constructive, destructive. We don't care, and we'll take anything. We'll take any criticism, because we want to try to make these videos as good for you, the people who are listening it, as possible. That's why we're here, to try to help you understand this stuff. Okay, have a great day, everyone.